Hi, it's Wheeler. I'm going to talk about simplifying radicals today, and it's a pretty easy process. A few years back, I came up with a stupid analogy. I love stupid analogies that will help you remember how to simplify radicals. We're going to use a game called Go Fish. It's a card game. Most of you have probably played it before. If you haven't, you need to get out and live a little and play. There's different ways to play it. There's professional Go Fish, where you have to get four of a kind to make a stack outside the hand. That's sponsored by Aces Wild Playing Card Manufacturing Corporation, and you can catch it on ESPN once in a while. It's riveting. You got to check it out. It's riveting. But we're going to steer clear of the professional Go Fish. We're going to play a little kid Go Fish, where you only need two of a kind to make a stack outside your hand. Now, let's take a look at some radicals here, and I'll show you the analogy that I'm talking about. So you see a square root. That's going to be our hand of cards. And if we can simplify that, we will put stacks of cards outside. Now, the reason this works, we know that 9, if you look at the list up here, here's the list of perfect squares up through 6 squared. So 9 can be written as a perfect square, 3 squared. Now, like multiplication, division, addition, subtraction, a square root and a square are inverse operations, so they undo each other, and this would just be equal to 3. Okay. So all we have to do is look for pairs. So like 25, I can see 25 as a pair of 5s. And so once I have a pair, I can just make that stack outside. Now, if all the cards are gone out of my hand, then that hand is no longer there because it's a perfect square. So when we hit a case like this, 75, well, 75, that would be the square root of 3 times 5 times 5. I have a pair of 5s right here, so there's my stack outside. However, the 3 is a singleton, and since it doesn't pair up, it stays inside the square root. And so this is going to be equal to 5 square roots of 3. So when we look at it that way, it becomes pretty easy. In fact, we don't even have to rewrite it. If I look at 8, I know that 8 is a 2 and a 4, which is another pair of 2s. So I have a pair of 2s, and I have a 2 left over, so that's going to be 2 root 2. Same thing with 12. 12 is 4 times 3, but that 4 can be broken into a pair. And so this is equal to 2 root 3. Now 256, that's a whopper. And so with this method, it actually makes that pretty simple. We just need to remember how to tell when a number will go into another number. So like 256, it's even, so that's pretty sweet. We can always take 2's out. So I'll start by taking a 2 out, and then I'm going to get 128 left over. Now that's still even, so I can take a 2 out, and I get 64. Now 64, I'm thinking that's a perfect square, but you know, I'm just not quite sure, and this is going so smooth, I'm just going to keep up dividing by 2. And that gives me 32, 2. Oh, I know 16 is a perfect square. That's a 4 and a 4. So there's a pair of 4s. I have a pair of 2s. I've got another pair of 2s. So all of those go outside the radical. So I have a stack of 2s, another stack of 2s, and a stack of 4. I multiply those together, and I get 16. So 256 was a perfect square. It equals 16. Now what about 363? Well, it's not even, so I can't divide by 2. But we have another rule. This one's pretty slick. If you add up the digits, 3 plus 6 plus 3, you're going to get 12. And since 3 goes into 12, 3 will go into 363. That's one of my favorite rules. It doesn't matter how I organize these numbers. 3 is always going to go into it. So let's see. If I divide by 3, That's going to be a 1. That's a 2, and that's a 1. Look at that. We got a pair of 11s. So this is equal to 11 square roots of 3. So some of the rules of factoring help us out. So if it's even, we know 2 goes into it. If it adds up to a multiple of 3, we know 3 goes into it. That same rule applies to 9 as well. 4, if you divide it by 2 and it's still even, 4 will go into it. 5, if it ends in 0 or 5, it'll go into it. 6, well, that's kind of a combination of 2 and 3. If you divide a 3 out and it's even, then 6 will go into it because 2 also goes into it. 7 just flat out sucks. I don't know a rule for 7. And then 8 is kind of a continuation of 2, 4, 8. So that's just dividing out 8s. And we spoke about 9. And so that's pretty much it. So you guys have fun simplifying your radicals, and don't forget to check out Professional Go Fish on ESPN. Oh, one more thing I wanted to show you. We're going to be using these graphing calculators. One of the sweet things about it is if I have some decimal like 0.625, I can hit this math button and it will convert that decimal into a fraction. So I hit math and then just enter and enter again, and I see my fraction. Get that a little better. There we go. And so 5/8. Now let's say that I have the square root of 12. Well, if I try and change that to a fraction, it won't do it because that's irrational, because you still have a radical. But if you had a perfect square, let's say we had the square root of 12.25, and I hit math, enter, enter, it says quit, syntax error, because I didn't type it in correctly. So that old adage of garbage in, garbage out, if you compute a program, still applies to these calculators. And if you're wondering if I'm alone, the answer is no. Mr. Penner is in here, and you probably saw Mr. Hand just come into focus. So anyway, 7/2. And if you were to take the square root of 12.25, you'd see that it equals 3.5, which is 7/2, and we can play with math again. Boom, and there we go. Show.
Okay. Also, when you're doing your work, I'm going to jump in for a second. We said root 75 was 5 roots of 3 up here. I just kind of wanted to remind you that I love being able to check my answers. So when I did root 75, we got 5 roots of 3 a second ago. But keep in mind that if I type 5 roots of 3, I've changed what it looks like, but I should not have changed what it says. And so if I hit enter, I better hit 8.66 or I screwed up. So if you simplify it correctly, the decimal representation is better match. So I'm out.
So anyhow, when you catch on to this simplifying radicals, it's real simple. If you think about square root of 700, you got a 7 times 100, but 100 is a pair of 10s. So that's 10 root 7. So you'll see quickly, you'll be able to do these in your head. So for Mr. Penner and myself, we're out.